Hi everyone. In this given problem statement, we have to solve interleaving string. We are going to given three string and we have to ensure whether from joining the two string can we form the string 3. So the first thing, right, we need to check if length of S1 plus length of S2 should always be equal to length of S3. If there are more characters out here, then we can ensure, right, that using these two string we cannot never form the string S3. And it has been said that uh, a plus b is the concatenation of string a and b. So it is not like that you can remove few extra characters. You have to use all the characters that are present in S1 and S2 and you have to form S3. Now we can perform this using dynamic programming. So let's say we can define our function, let's say def, and let me do a dfs search. And here, right, initially, right, we are going to say I equal to 0, denoting the initial, let's say, length of s1 would be n1, this would be n2 and m3, and I can pass I and j, and j also is going to be 0. Now we have to check the base condition, right? So when can I say that n1 and n2 are forming n3? When I equal to n1 and j would be equal to n2. So I can say if I is equal to n1 and j would be equal to n2, then I can say return true. And this would be our base condition for this problem. Now let us take this example, right? Which is A, B, C, C. Then we have D, and we are taking this example on the top. D, B, B, C, A. Okay, and the given string is our A, D, B, B, C, B, C, A, C. Okay, now our I is 0 and J is 0. Now I plus J is also 0, right? And we can add in condition, right? If our I is less than n1 and I can say s1 of I, if it's equal to s3 of I plus j. So if that is the condition, right, then what I can do, I can call in and you can store this value, and initially, right, I can say the result, right? We are assuming that it is false for the now. So the result would be DFS of, because you have already checked, right? So we are going to remove this one and increment I by plus 1. And we are going to say I plus 1 and j would remain the same. Now we are going to do the same thing again, and this are common, so we are going to remove it and increment to 2. Now we are going to reach to this condition, right? Now it is going to fail because s of I1 is not equal to s3 of I plus j. Then we can write another condition, which is if j less than n2 and here, right, we have to give it or. The reason being, right, because there will be multiple formation, right, of this DFS. It can go in multiple direction. So if the idea is right, if there is any way that we can form string 3 using all the characters of S1 and S2, we have to return true. any one would be fine. So here, right, I can say S2 of J is equal to S3 of I plus J. Then I can say result equal to result or DFS of I is remaining same, J plus 1. So D and D we're going to remove, increment to 1. Then B, right? So B, we can remove any one of them, so it doesn't matter. So let's say we are going to remove it for I and make it 3. So now there is another B, so we can remove it from D now. Then we have C, so remove it from here, increment to 4, remove it. Then we have B, remove it. Then we have C, we can remove it from here. Then we have now, right? See here, there is one more catch, right? Because if we remove this C, right, and this is the reason we need dynamic programming. So if we remove C, right, we cannot never go with A and C. Okay, so we cannot remove this C because if you look into the dynamic program, it is going to form a tree-like structure. So instead of this, right, what we're going to do, we're going to keep this C, remove this C, and then remove A, and at last remove this C. So this would be the idea. And at last, right, I can say the return result. So, and when you're going to call this function, it would be DFS of 0 and 0. So this is a dynamic programming, and if you look at the time complexity, right, it would be basically length of S1, which it would be N1 multiplied by N2, or I can say in simple terms N square. And this would be the time complexity, and the space complexity would also be N2, because we are going to form at the end, right, a recursion stack of N square, right, which would be pretty high. Here also one more thing to understand, right, because it is N square, it will be like tree-like structure, right? To come into this, right, you have to introduce dynamic programming. So I can say DP, I can introduce a hash set, and here I can say if I and J in DP, then I can return DP of I and J. And similarly, right, here I can say DP of I and J is going to store our result, and at the last I can return DP of I and J is the response. So this is the entire problem, and it's pretty straightforward if you understand the concept of recursion. And once you understand the concept of recursion, then your problem is solved. But now to improve your efficiency, you need to introduce dynamic programming. So once you introduce, right, or once able to come up with the solution, right, then adding dynamic programming to your problem is not that hard. So first try to look into the recursive solution, and then try to add memoization to your problem using a hash set or however you like to do it. So you are able to solve the problem, and this the problem I have shown it in recursive plus memoization. There would be also a top down approach, sorry, bottom up approach or tabulation method. I would ask you to maybe look into that and try to experiment with it. But I think for most people, right, the recursive and memoization solution would be good enough. Saying that, let's jump to the Python solution. The first thing that you need to calculate, right, let me calculate the length of our all these strings. So length of S1, then N2 is going to store the length of S2, N3 is going to store the length of S3, and now I am going to check if N1 plus N2, if it's not equal to N3, then we can safely assume, right, using this two string we cannot never form the n3. So I can say return false. Else, right, I can say do a dfs, and here I can call in my function and I can pass in the parameter which would be the index I and j, and the base condition, as I have told, right, if I equal to n1 and j equal to n2, both of them needs to be equal to n1 and n2, then only we are going to say return true if I and j is in dp. We have already calculated it. Then I can say return dp of I and j, and also we need to introduce a memoization. So let me say dp of a hash set. Once that is done, right, I am going to assume initially, right, the result is going to be false. Now I am going to check if we also need to check in, right, if in case I exceed it, right, then it is going to give us an error. Let's say if we keep on incrementing the I, then in that case, right, it is going to throw a error saying that index out of bounds. So we have to check that also. So I should always be less than n1, and if s1 of I is equal to s3 of I plus j is true, then I can say result equal to result or, so it's a boolean, right? So false and true becomes true, false and false, false or false becomes false, true or false become true, and true or true is true. So that is the condition, right? So we have to basically calculate, right, if even if there is one way of forming s3 using n1 and n2. So that's the idea. So that's why writing result or, and I can say dfs, because we are using one character of s1, so it would be I plus 1 and j. Similarly, if j less than n2 and s2 of j is equal to s3 of I plus j, in that case it would be result equal to result or dfs of I and j plus 1. At last I can say, or I can add it to our dp of I and j. We have got already the value which is going to be a result, and I can return dp of I and j. Now I can return dfs an initial value of I and j, because they're starting from the 0th index would be 0 and 0. Let me run the code. Yeah, I think, yeah, I made one simple mistake. Let me run now. As you could see, the public test case is passed. Let me submit the code. And all the test cases passed, and it's beating 43.93, which is pretty efficient. Maybe if you use the tabulation method, it can improve your efficiency a bit more, but I think for most of your technical interviews, right, this would be good enough. And now it says beating 88.03. So anyway, it's pretty good actually, the solution that you have created. So you just need to show in one way, mostly one way of, either you can choose recursive or recursive with memoization or a tabulation method. It's up to you, top down or bottom up. Saying that, that's all for this video. See you in the next one.